what if we have u equals e to the x? Well, if we take the log of both sides, we get the natural log of u equals the natural log of e to the x. And what's the natural log of e to the x? Well, that's just x. And the natural log of u. And so now if we take the derivative of both sides, we end up with 1. And the derivative of natural log is u prime over u. Now if we multiply both sides by u, we end up with the result u prime equals u. Okay, well, what is u? Well, u is what we started with, e to the x. In other words, the derivative of e to the x is e to the x. And that's huge. So e to the x is the only function that when you take the derivative, you get itself. Okay? So there you have it. Okay? The derivative of e to the x is e to the x. All right? Or if we have a function up here, we've got to use a chain rule. Then we have u, the derivative of the inside, which is u prime, times e to the u. All right? So that's just the chain rule. So the second one's just the chain rule, the first there. Okay? So how about this? What is it if we got y e to the x squared plus x minus 3? Well, that's just going to be derivative of the inside. This is the inside here. Derivative of the inside is 2x plus 1. The derivative of the outside is just e to this power. Well, we just found out that e to the x, the derivative of e to the x is e to the x. So the derivative of e to the u would be e to the u, or e to the x squared plus x minus 3. That's it. Okay, so that's the chain rule there. Okay. How about this? Got a little chain rule going in reverse here. So we got to take the derivative of the inside. Well, what is the derivative of e to the x? It's e to the x times the derivative of the outside, which your sign is cosine e to the x. That's it. Okay? Super easy. Derivative of e to the x is e to the x. And what if we have a different base instead of e to the x? Well, we got to remember this. If we have some number a, we can write that as e to the natural log of a. Okay? E to the natural log of a. Well, just to convince us that that is what we think it is, ask ourselves, what is natural log of a? Well, natural log of a, that's like, remember natural log has a base e that we don't write. Okay? Well, the natural log of a is a number. It's a number that we can put on e to get a. Okay? So that number, and if we take that number and we put it on e, well, what do we get? We get a. All right? All right. You can also think of it this way. Natural log is the inverse of an exponential. So these kind of cancel each other out. Okay? So since a is e to the natural log of a, that means that 2 is e to the natural log of 2. All right? So e to the natural log of 2 is 2. Because natural log of 2 is the power you put on natural log, or you put on e, sorry, to get 2. So let's replace this here. This is e to the natural log of 2 to the x. Now this is a long route. We're going to find a shortcut in a minute. Using our power to power rule here for exponents, we can multiply these two. This is e times the natural log of 2 times x. Power to power we multiply. Now let's take the derivative. We're ready for the derivative. Y prime, well, this is e to the u, so we're going to use a chain rule. The derivative of u, the derivative of that top stuff, yeah, well, what is the derivative of the natural log of 2 times x? That's just the natural log of 2. Because natural log of 2 is really just a constant. Times the derivative of the outside. Well, the derivative of the outside is e, natural log of 2 times x. Because e doesn't change, right? Okay. When we take that derivative, e to the u is e to the u. Okay. Well, one more thing. We're going to go ahead and convert this back again. Okay, we can write this like e to the natural log of 2. Okay, and well, we just know that e to the natural log of 2 is 2. So we have natural log of 2 times, put that in parentheses, times 2 to the x. There it is. Well, we said that the derivative of e to the x is e to the x. So we might say, hey, I think the derivative of 2 to the x should be 2 to the x. Well, it almost is. Derivative of 2 to the x is 2 to the x, but then we have this conversion factor of the natural log of 2. Okay? So that's the key. We have the conversion factor of the natural log of 2. So if you want the derivative of a to the x, where a is not the natural number e, you get the natural log of a times a to the x. Okay? So what do we have here? Using that rule, we've got the 4 to some power. Okay? So we got a chain rule. So let's take the derivative of the inside, that's derivative cosine, that's negative sine x, times the derivative of the outside, that's like 4 to the u. So it seems like we should just be able to copy it down 4 cosine x, but since it's a 4 and not an e, we've got to multiply by the conversion factor of the natural log of 4. All right? And that's about it. We might just clean it up a little bit. We might like, I don't know, negative natural log of 4 times the sine of x times 4 to the cosine x. Doesn't really matter. You can put it in lots of orders, but there you have it. Okay, so again, the derivative of natural log of e to the x is e to the x. The derivative of natural log of x is just 1 over x. And one more while we're at it. The derivative of natural log of u is u prime over u. All right? And then if we have a to the x, well, we've got to have that conversion factor there. All right? Well, great job. Keep working at it. You'll get it. These are special power, special rules that we'll use all the time because it's our natural number. Shows up all the time in calculus. Great job. Keep it up. Thanks a lot.